All right, so let's tie together everything we've learned about transformations of trig functions. All right, so let's say that f is just a sine or cosine function. So I have like a times sine of b theta minus c plus k, or it could be cosine, so sine or cosine. All right, if that's the case, then as we've learned, the amplitude will be the absolute value of a. The phase shift, or the horizontal shift of the function, will be c divided by b. So remember, if it's minus c, then we'll shift it to the right. If it's plus c, we'll shift it to the left. The period will be 2 pi divided by the b here, or if it's in degrees, it'll be 360 degrees divided by the b. And the midline, of course, is k, or the vertical shift is k. So what we're going to do is we're going to look at a graph, and we're going to try to write a function for it. Okay, so let's go for it and see what we got. So notice first of all that this function has a period of 90 degrees. Okay, it goes through one full cycle between 20 degrees and 110. So 110 minus 20 is 90 degrees. So the first thing we notice is that the period is 90 degrees. So let's go ahead and label some more points now. So if this is fully 90 degrees, then half of this would be 45. So 20 plus 45, this would be 65 degrees here. And then halfway between 20 and 65 is 42.5. I'll slide that right in there. So 42.5 degrees. And halfway between 65 and 110 is, let's see, let me pull out a calculator. 65 plus 22.5, that's 87.5 degrees. All right. So let's see what else we can figure out. So our period is 90 degrees. What about the amplitude? And the amplitude is really easy to see. So this function rises 5 units above the midline, 5 units below the midline. So the amplitude is 5. What else can we notice really quick? So maybe we want the phase shift, or how far it is been shifted. The phase shift is 20 degrees. And the midline, that's really easy to see. The midline is at 3, so the vertical shift is 3. All right, so we know everything we need to know about this. Is this sine or is it cosine? Well, it could be either one. It could be sine or cosine. So there are different functions that will give us this same graph. But when I look at this, I see that it starts on the midline. A sine usually starts on the midline. The basic sine function starts at the origin, and it goes up to 1, back down to the midline, below the midline, back to the midline. And that's what this does. It starts at the midline, goes down, back to the midline, above it, below. But it's upside down. Okay, so this function should be negative sine. All right, so let's see if we can write this function. Okay, so let's call this t of x. All right, my amplitude is 5, but it's been flipped upside down. So I know that this a should be negative 5. And we said we were going to use the sine function. Again, you could use cosine, but you would have to shift it in different ways. All right. So we have sine of something. And the k is really easy. The vertical shift is 3, so we know we're going to have plus 3 out here on the end. All right. So all we need now is this b and this c. Okay, let's see if we can figure that out. All right, so I know my period is 90 degrees. And I know that the period is 360 degrees divided by B. So what's B? All right, so my period is 90 degrees. And I know that period is equal to 360 degrees divided by B. So if I solve this equation, multiply both sides by B, divide both sides by 90, I better work that out. Multiply both sides by B, and then divide both sides by 90. I get B is equal to 360 degrees divided by 90 degrees. My degrees cancel, so this is just a pure number. 360 divided by 90 is 4. So I know my B is 4. So I have 4 times theta. I just been shifted to the right, so I know this is going to be minus. So now all I have to do is figure out what the C is. Right? And the C involves the phase shift. So I know my phase shift is, I'm out of the room here, my phase shift is 20 degrees. And 20 is equal to C divided by B. We've already figured out what B is. B is 4. So it's really easy to find C. Then multiply both sides by 4, and I get 80 degrees. So minus 80 degrees. And there is a function that gives me this graph. Again, it's not the only function. I could have a function involving cosine, but my shift in here would be different. My phase shift would be different. So these numbers inside of here would be different if I use cosine. There are also other graphs with sine that use different numbers in here where I just shift it farther one way or the other. But this is the one that works. Let's test it out and make sure. So let's plug in some numbers. So I'm going to plug in 20 degrees. When I plug 20 degrees into this function, I better get 3 out of it. Let's see if I do. All right, so I put 20 degrees in for theta. 4 times 20 degrees is 80 degrees. Minus 80 degrees is 0. Sine of 0 is 0. 0 times negative 5 is 0. 0 plus 3 is 3. Awesome. Let's try 87.5. Okay, so if I put 87.5 in for theta, 4 times 87.5, let me pull out a calculator. 87.5 times 4 is 350 degrees. 350 minus 80 is 270 degrees. The sine of 270 is negative 1. Negative 1 times negative 5 is 5. 5 plus 3 is 8. Boom, that's exactly what it should be. So we can be confident that we got this correct.